Here's a centre of mass question from Edx M2 January 2010, question number 7. Pause the video and have a read of the question. It looks a little bit off-putting, it's not as bad as it looks, but at first glance it doesn't look very friendly. Right, we've got a uniform plane lamina and it involves a rectangle and two semicircles. So we need to make up a table of masses, and I've done that on the next page. I already filled this in because it was a bit fiddly fitting it in on the screen, and I thought I'd better try and fit it all in first and then go through it. So all I've got here, first of all, in the diagram, I've shown the masses of the component parts, the rectangle here and the two semicircles. You might like to pause the video and check those masses. The masses are effectively just the areas. So this is 24x, these are 4.5 pi and 4.5 pi each. The distances, what I'm going to put in the table is the distances of the centre of mass of each of these three from the dotted line SR. So for the 24x, it's a distance x below it, and for the two semicircles, using the result on the top of the screen, near the top of the screen, this result here, the distance of the centre of mass of a semicircular lamina, 4r over 3 pi from the centre of the lamina, which would be there. Now with the radius being 3, 4r over 3 pi simplifies to 4 over pi. So these two masses then are at a distance of 4 over pi from the dotted line SR. But that's on the other side from the centre of mass of the rectangle, so we have to be careful with signs when we take moments about SR. So just again, you might like to pause the video and just check that all of these are in the right places. The total mass for the whole shape then is 9 pi plus 24x, and we're trying to find the distance from SR. What we have to do is take moments about the line SR. Total mass times its distance is masses times their distance, but watch out because the moments are effectively in different directions for the two semicircles and the rectangle. The maths will take care of that if we make sure we put the sign in for the distance as negative for the two semicircles, okay, and positive for the rectangle. When we do that, the moments equation becomes what I've got written down here. Okay, I won't read that all out to you. It's straight from the table. And rearranging that, well, first of all, that's what it comes to when the pi's cancel. And then rearranging that to get x bar, we get the expression they've got here, which simplifies to this expression. And I've just run out of room. The expression they wanted was exactly that, except they had taken a 4 out of the top. So we've got to the answer they wanted. Just to prove to you, I'm just going back to the previous page to save you doing it. So here's the answer they wanted. 4 times the modulus is only in there because they're asking to show that the distance is that much. Now the distance would be positive. In my answer, which has got an 8x squared minus 12 on top here, depending on the value of x, the 8x squared minus 12 could work out negative. This distance could work out negative, depending how big or how thin the rectangle is. So our value of x bar gives the distance, but with a plus or minus sign. So it would get us the marks. Okay. So we're there. We've got the answer they want. It just needs a 4 taken out of the top to get exactly the same answer. I won't rewrite this all again though, just for that. And that's the first half done. Now for the second bit. Okay, for the second bit, we now hang the template, hang the shape from the point P. We hang it from there. We know where the centre of mass is, we've just found it. We've just found x bar, an expression for it. And we want to find the angle that the line the angle at the side PQ mixed with the horizontal, beg your pardon. Now, I'm so used to finding the angle it makes with the vertical that I've done that in this case, and then just amended that to find it with the horizontal. So let's go through this. As far as the template hanging in equilibrium from P is concerned, the vertical will be the line PG, where G is the centre of mass, and we know X bar from the first part. They tell us that for this part of the question X is 2, so we know that this length is 4, this length then is 4, so this is 4 minus X bar from G to the base. So we can work out 4 minus X bar by using the result that we've got from the first part of the question, and then we can work out tan alpha, 4 minus X bar over 6. Okay, and that'll give us the angle with the vertical. So here we are. Oh, I've already done the swap here to get the angle with the horizontal. So if tan alpha gives us if alpha is the angle with the vertical, and tan alpha is 4 minus X bar over 6, the angle with the horizontal is 90 minus alpha. So if I call that theta, the tan of theta will be 1 over the tan of alpha. Okay, or cot of alpha. So tan of theta will be 6 over 4 minus X bar for the angle it makes with the horizontal. Now the rest of the question is just a matter of putting in the fact that X is 2 into X bar, which is this expression from the first part, and carefully working out an expression for tan of theta. We don't need to find the angle, we just need to show that we get the right expression as they do for tan of theta. Okay, so again, pause the video if you need to and check these steps for tan of theta. 6 over 4 minus X bar, and then it gives what they've got in part B. So not the nicest question, a bit messy compared to some of them, but not as bad as it looked, I don't think. Let's just go back quickly and look at the marks. In the first part of the question, for a total of 7 marks, there was 4 marks for making up this table correctly. A B2 for the masses and a B2 for the distances. And then there were another 3 marks for taking moments, a method mark for taking moments, an accuracy mark for putting the correct terms and the correct positive and negative signs in, and an accuracy mark for getting the correct expression for X bar. 7 marks for that first part of the question. For the second part of the question, there was 4 marks. Just waiting for it to come up. Alright, there it is. And the 4 marks are, as you see there, putting X equals 2 in and finding the new value, or the value of X bar if X is 2, a mark for that. A method mark for using the triangle to find, well, tan of theta. I found tan of alpha first and then did the reciprocal of it. So a method mark for that. An accuracy mark for putting the right expression in, and for then tidying it up, another accuracy mark for the answer. Okay, that was question 7 from January 2010.